Kia ora, 13 Cambridge. Sorry I'm not in again today. So just to finish off what we started yesterday, on Monday, looking at partial fractions, I was about to go over the example where we've got on the bottom an ax plus b, and where we've got a cx squared plus d, or any form of x squared inside the bracket. In the last lesson, we looked at when there was a squared on the outside, and that meant that we had to do a single version of a bracket and a squared version of a bracket. But now the squared is on the inside, it's slightly different. The way it gets split up is to be rewritten as a over the ax plus b, and then bx plus c over cx squared plus d. Okay, so let's have a look at that in practice. So if we've got 8 plus 2x minus x squared over x minus 1x squared plus 2, just to quickly recap as well and double check, the thing on top, the polynomial on top, has to be a lower power than the polynomial on bottom. At the moment we've got squared on top, and this would be a cubed from the x and the x squared. So we can do our partial fractions here. So we're going to get a over x minus 1 plus bx plus c over x squared plus 2. Okay, when we times through by our x minus 1 x squared plus 2 like we did in the previous lessons, what that's going to give us is 8 plus 2x minus x squared is equal to, so timesing this by this, the x minus 1s will cancel out, leaving me with x squared plus 2. So that'll be a x squared plus 2 plus, when I times the bx plus c by x minus 1 x squared, the x squared plus 2's will cancel out, but all of the bx plus c will be multiplied by the x minus 1. So I like to write an extra step, which I don't think they've written in the textbook, but I would have written this as plus x minus 1 bx plus c, which would then become 8 plus 2x minus x squared is equal to a x squared plus 2 plus bx x minus 1 plus c x minus 1. Okay, with the expansion of this this bracket times those two parts. Rather than doing x times bx and minus 1 times bx, it's easier just to keep the bx and the c. That way, when we do our cancelling out, we can just cancel out a's, b's and c's relatively easily. Okay, so let's think of what we can sub in to cancel something out in this question. So I'm going to start off with substituting in x equals 1, okay, because if I sub in x equals 1, it's going to make this become 0 and this becomes 0, leaving me with just my a term. So we're going to use x is equal to 1, which gives me 8 plus 2 lots of 1 minus 1 squared on the left is equal to a 1 squared plus 2 plus b lots of 1 minus 1, which will be 0, and c lots of 1 minus 1, which would also be 0, giving me, well, let's actually write this out. So 8 plus 2 minus 1 is 9, is equal to 3a, and nothing else, and a is equal to 3. Cool, so that is a. The next thing to consider is how we can find our remaining values. Okay, because we've got x squared plus 2, technically there's multiple different values that you can substitute into make that become 0 because you can use the positive and negative answer. But what we're going to do instead is we're going to substitute in 0, okay? Because if we substitute in 0, that's going to get rid of our b term, okay? Because there's a single x here, we can just use x equals 0, and it will get rid of this. And because we know what a is, we can substitute it into here as well, which means that this will disappear. We'll know what this is, just leaving us with the c value, okay? So we're going to sub in x is equal to 0, and then that's going to give us 8 plus 2 lots of 0 minus 0 squared is equal to a, which we know is 3, so 3 lots of 0 squared plus 2, plus b lots of 0, 0 minus 1, which will just disappear, plus c lots of 0 minus 1. This gives us 8 is equal to 6 minus c, which gives us 2 is equal to minus c, which means c is equal to negative 2. Now we know a and c. Rather than trying to work out how we could cancel out the a term with squared being involved in there, or then substituting in our values for c to find b, it's much easier if we just substitute in any value and use the a and c term that we already know. So we've used x equals 1 and we've used x equals 0, and general rule of thumb is you always want to use the easiest value of x, and the easiest value of x is 0, and then the second easiest value of x is 1, and those two are already taken. So you're just going to have to choose another one. You can choose to use x equals -1 like they show in the book, because -1 is generally relatively easy. However, if you struggle sometimes with your negative signs, it might be easier just to choose a positive number, which you can put in there. But I'm going to use x equals -1, but you can use any number in this case. So that's going to give us 8 plus 2 lots of -1 minus -1 squared is equal to my a term, which is 3, and then x squared. So I'm going to put a bracket around this because it's all of -1 squared, it's not -1 squared, plus 2, plus my b, which I don't know, -1, -1, plus my c term, which I do know, so actually that's -2, -1, -1. Okay, so replacing all of my x's with -1, and my a and c with the values of a and c. So that's going to give me 8 minus 2 minus 1, because the -1 squared will become +1, so just 8 minus 2 minus 1, which is 5. And that is going to equal -1 squared, which is 1, plus 2, which is 3. 3 times 3 is 9, so that will be 9. -1 minus 2, so that's going to give me +2b, and the -2 times -2 is going to give me +4, so that's going to give me 13 from the 9 here and the 4 there, so 13 plus 2b, which is -8 is equal to 2b, which is b is equal to -4. Now it's just about writing our answer in its final form, so that will be looking like this. Okay, so 8, oh, wrong pen, 8 plus 2x minus x squared over x minus 1, x squared plus 2, x minus 1, x squared plus 2 is equal to my a term, which is 3, over x minus 1. Sorry, that was not good. 3 over x minus 1. My b term, so that I could take a negative because it's minus 4x and minus 2 on the thing. so I could rewrite this as a minus positive 4x positive 2. I'm just going to make it easier on myself at the moment and just say plus minus 4x minus 2 over x squared plus 2. But as you'll notice in the textbook, the way they've rewritten that is 3 over x minus 1 minus positive 4x positive 2, because when we take the negative out of a 4, we should also take the negative out of a 2. We'll change the sign, at least. If that was a positive in front of a 2, that should become a negative. Over x squared plus 2. Okay, so that's the last case. So there's 3 cases what can happen, which is you've just got brackets times together, so you just split them all up like so. Something involving a squared, so a squared in itself can be split up into a single version plus the squared version, which obviously can be combined with the first example. And the last one is where the squared is inside the bracket. You rewrite the squared part as being bx plus c over the squared part. Okay, the last thing is this question here. So I keep referring to the fact that the numerator is a smaller polynomial than the denominator. In this case here, it's not. Okay, so the first step you have to do when the polynomial on top is greater than the polynomial on the bottom is you need to divide in the same way you would with a standard number, such as 5 over 4. You wouldn't go, oh, well, you know, that's split. If I was to be able to split up, or I could rewrite that as 3 over 4 plus 2 over 4. This would be silly. You would consider the fact that 5 over 4 is actually 1 and 1 over 4. So what we're going to do is we're going to find the 1 first by dividing, and then the partial fraction that we might need to create afterwards. Okay, so first step is to do a long division. So we're going to do x squared plus 2x minus 3 into the long division of 2x squared plus 5x minus 11. And I'm going to just do this quickly because we've done this a few times recently. So I need a 2 here, so it's going to be times by 2. So 2 times the x squared plus 2. So let me rewrite that. 2 times x squared plus 2x minus 3 gives me 2x squared plus 4x minus 6. And when I take that away from the line above, the x squareds cancel out. 5x minus 4x is 1x. And then minus 11 minus 6 is minus 5, sorry. So that means that I can rewrite this fraction as 2 plus x minus 5 over x squared plus 2x minus 3. Now it's rewritten like this. I can express my my fraction as partial fractions. So the partial fraction I'm going to focus on is the x minus 5 over x squared plus 2x plus 3. So I'm just going to do this separately to the 2 for now, and then we'll throw the 2 back in at the end. So split like that. So x squared plus 2x minus 3 is not currently written as a factorization. So I'm going to have to first write it as x minus 5 over the partial fraction, which is x plus, sorry, the product, x plus 3 times x minus 1, which can be rewritten as a over x plus 3 plus b over x minus 1, then going to times through by that quadratic, giving me x minus 5 is equal to a x minus 1 plus b x plus 3. The value of x that will cancel out for a is x is equal to 1, so 1 minus 5 is equal to a lots of 1 minus 1 plus b 1 plus 3, giving me 4b is equal to minus 4, so b is equal to minus 1. I then need to find my b term, so I'm going to use x is equal to minus 3 to cancel out on the b, which gives me minus 3 minus 5 is equal to a lots of minus 3 minus 1 plus b lots of minus 3 plus 3, so it's going to disappear, giving me minus 8 is equal to minus 4a, so a is equal to 2. Now I can go back and put it into my partial fraction, and once I put it into my partial fraction, I can just say 2 plus that. So the final answer is going to be rewritten as 2x squared plus 5x minus 11 over x squared plus 2x minus 3 is equal to 2, plus my a term, which is 2 over x plus 3, and my b term, so minus 1 over x minus 1. Okay, and that's it. So if the polynomial on top is greater than the polynomial on bottom, first thing you have to do is divide and then do partial fractions. Okay, so that's it for partial fractions. Hopefully that makes a bit of sense. If it doesn't, potentially send me a few messages on Teams and I might be able to answer them. We'll see how I'm going. Alright, thanks. Bye.